Okay, so today we are going to discuss the status specific orientation. So first in this topic we are going to understand the concept of the transfer function in classical approach. What to understand by the transfer function in the classical control theory, right? In classical control theory. So any, you can say, any dynamic system, any dynamic model, you can say, or the system derived from physical, you know, rule, you can say. Physical rule means, let's say there is a mass balance equation, mass balance uh, spring problem. So in order to develop the model of that mass spring damper problem, we just apply the physical law, right? And you are able to find the model. Okay, so and the model, obviously the model will come in the picture of the dynamics equation, right? First order differential equation. You can say that typically consists of one or more ODE. ODE means ordinary differential equation. So the model will come in the form of the differential equation. Agree? Yes or no? Most of the equation will come on into the, क्या कह सकते हैं बेटा? Yes, please. That will come into the dynamic equation. Am I audible? Yes or no?
Yes, sir, audible.
So in order to relate that model, in order to relate the model, right, input and output, just we are mapping the input and output and finding, and we'll try to find the transfer function. ओके, सो इनपुट आउटपुट जब कहते हैं तो सिंपल हम बात करते हैं SISO सिस्टम की, इस सिंगल इनपुट सिंगल आउटपुट. ओके, इन टर्म ऑफ रेशियो, yes or no? In term of ratio, that is the output divided by the input. Okay, and this ratio in the Laplace form is known as, the transfer function, right? So you can say here, and also whatever the initial condition, or the initial equation obtained by writing transfer function, okay, of any physical system. Okay, और ये बात याद रखें कि this is only for the lumped system, not for the distributed. I am only talking about the lumped system. What is the difference between the lumped and distributed system? I will discuss in the PDC, process dynamics and control. So it is generally the equation will come in the form of the ODE, ordinary differential equation, right? Now, and you also know, when you are taking the output ratio to the input, then this ratio should be taken in the form of the Laplace, or you can say, in order to define the transfer function, we use Laplace transform. Yes or no? Laplace transform. Okay, so let's say considering a general term, let's say हम general term में consider कर रहे हैं for system representation. Let's say I'm going to represent some system where xit is, let's say, the input, and x naught t is, let's say, the output. Xit is the input and x naught t is the output. Okay, so what is the generalized equation? The generalized ODE relating the input and output is like this. इनपुट आउटपुट कैसा होगा? वो होगा एक, वो होगा आपका किस तरह से, कहाँ गया कहाँ गया, सॉरी, यस, वो होगा कुछ इस तरीके का कि अगर आप लिखें जनरलाइज्ड ordinary differential equation which relates the output and input in the form of the differential equation. So ध्यान से देखना, और if you are not able to understand please let me know, तुरंत बताना. This is the output an minus 1 dn minus 1 dtn minus 1 dx naught t plus an minus 2 dn minus 2 dtn minus 2 x naught t plus dot 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 a1 d by dt of x naught t plus a naught x naught t. ये आउटपुट है. In similar way we can write the equation for the input side, dm by dtm xit plus bm minus 1 dm minus 1 dtm minus 1 xit plus dot 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 b1 d by dt of xit plus b naught xit. So this is nothing but the relation between the input and output relation in the form of the ODE. किसी भी डायनेमिक सिस्टम को मैक्सिमम, if it is a lumped system, then we can represent that system in the form of this. It is a generalized equation. Agree? Yes or no? Yes or no?
Yes, sir.
जैसा आपने मास डैम पर प्रॉब्लम में देखा तो आपका वो फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन आया, यहां से यहां तक आया था, और इज इक्वल टू समथिंग आपका कांस्टेंट टर्म, ये वाला बना था. यस और नो?
Yes, sir.
Yes.
So now I am trying to take the Laplace transform. Take the Laplace transform. Applying, you can say applying Laplace transform without, important thing is initial condition. Without initial condition. Right? Without initial condition. What it mean? It means why you are choosing the initial condition 0? Because if you are not taking the initial condition 0, then the system become non-linear. The system become non-linear. How? We will see from the one example in the PDC. Right? Don't worry. So अब इस पर लाप्लास लो जरा. तो लाप्लास लोगे, व्हाट इज द लाप्लास ऑफ dn by dtn of x naught t?
Sir, s to the power n
s.
आ जाएगा.
तो यहाँ लिया x naught s, अगर हम कॉमन ले लें तो it is a n s power n. Am I right?
Yes, sir.
Yes,
If
sir.
it n a n minus 1, ये क्या बन जाएगा? s to the power n minus 1
S power n minus 1.
plus dot 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 up to the a1 s फर्स्ट ऑर्डर के लिए प्लस a naught, क्योंकि a naught into x naught s जो हमने कॉमन ले लिया बाहर. Is it clear? In similar way, we can take the Laplace transform for the input side. So you can write here the xis we can take common, and rest of the thing where you write as a bm s to the power m plus bm minus 1 s to the power m minus 1 plus dot 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 up to the b1 s plus b naught. If I am not wrong, then this is the relationship between the output and input. Yes or no?
Sir.
Yes or no?
Yes.
Okay.
Yes, sir.
So now just you take the output, a ratio of output and input, that is the x naught s upon xis, and this is it is called the transfer function, because the transfer function is defined as the Laplace transform of output upon Laplace transform of input, putting all the initial condition 0. Okay, so when you are saying these things, it means you have the equation like this: bm s power m plus bm minus 1 s to the power m minus 1, okay, plus dot 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 up to the b1 s plus b naught divided by an s power n plus an minus 1 s power n minus 1 plus dot 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 a1 s plus a naught. So this is the transfer function. Am I right? Yes or no? So
Yes,
this
sir.
transfer function
Yes, sir.
may be written as the x naught s upon xi s in the form of, you can say, the numerator and the denominator ns and ds. Okay, so we can when you write in the form of the polynomial, that is s plus minus z1, s plus minus z2 and so on, हम ऐसे इसको रिप्रेजेंट कर सकते हैं. And in the denominator side, s plus minus p1, s plus minus p2 and so on. Yes or no? इसको फैक्टराइज करके ऐसा लिख सकते हैं. Yes or no?
Yes,
Please
sir.
tell me.
Yes, sir. 0.
So where k is known as the system gain, where z1, z2
Whole.
and all zn is known as, yes, please tell me,
Zeros.
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 Zeros. Zeros of the
And
system.
And P.
p1, p2 and up to this pn is known as the poles of the system.
Poles of the system.
Poles of the system, right? ये आपको पता है, इतना आपको बात पता है. अब नाउ कम टू द नेक्स्ट पॉइंट, दैट इज द, आप इस इक्वेशन को याद रखेंगे कुछ देर के लिए. दिस इज वेरी वेरी इंपॉर्टेंट इक्वेशन नंबर 1. प्लीज रिमेंबर फॉर द सम टाइम. So now, when you write, let's say I am taking the ratio of B naught upon A naught, B naught upon A naught, okay, B naught upon A naught. So this is called the zero order system, zero order system, okay. And the best example जो मैं कल भूल गया था, मैं आपको बता रहा था कि I forgotten. The best example is, you know, the potentiometer. Potentiometer. Yes or no? When you supply some voltage, okay, that constant will come and then depend on the, you know, the length of that wire. Yes or no? Xi something is
Yes,
coming
sir.
like this one, right? The constant, so linear curve is here, there, potentiometer. So this is the zero order system. So anyone, when you talk about what is the zero order system, the constant term will be the zero order system. Now when you talk about the b naught upon a1 s plus a naught, then you can write here b naught upon a1 and s plus a naught upon a1. You can write here like this one also, or you can also write like b naught upon a naught divided by a1 divided by a naught s plus 1. May I write? Yes or no? Yes or no? b naught a naught अगर कॉमन ले लें हम लोग, तो b naught upon a naught divided by a1 upon a naught into s plus 1 लिख सकते हैं ऐसा. Or it is nothing but the
Yes, sir.
k upon tau s plus 1, k upon tau s plus 1, k, where k is the b naught upon a naught and tau is nothing but the a1 upon a naught. So it is the representation of the first order system. Yes or no? It is the
Yes,
representation
sir.
of
Yes,
the
sir.
first order system. First order system, right? First order system. Now if you take the b naught upon you can say that a2 s square plus a1 s plus a naught. So this is the form of the second order picture, second order system, okay, second order system. So now I assume that you all are aware of this first order, second order and zero order system. Now please tell me, there's a one problem. 1 upon s plus 1 is the transfer function of any certain system. So what is the type of the system? And please comment on the type and order of the system. Please comment
Sir,
on the
type
type
0,
and
type 0, type
Type
0, order 1.
0. Order 1.
Type 0.
type 0 and
Order 1.
Order 1.
order 1. Type 0 and order 1.
Order 1.
ओके, ठीक है. So what is the type and what is the order? First of all, tell me. Then I will move
Sir, number of
for.
pole at origin. Describe the type.
Okay. Type means number of
All
poles
at origin.
lie at origin.
Origin.
Okay. Wait a minute.
Yes, sir.
Wait a minute. So number of poles lie at the origin, and also it is very important. और कुछ कोई बता सकता है? What is the type? Please, anyone? Any comment? Any comment? Please. Any comment? Other? Beside this? नहीं बताओगे? बोलो भाई, बोलो.
Sir, power of S.
नंबर ऑफ पोल लाई एट द ऑरिजिन. और इसको आप याद रखें, बहुत इंपॉर्टेंट बात है कि द टाइप इज डिफाइंड. आप ऐसे समझें कि एवरी ट्रांसफर फंक्शन आर रिप्रेजेंटिंग द कंट्रोल सिस्टम इज ऑफ पार्टिकुलर टाइप एंड ऑर्डर. एग्री? हर जो आपका ट्रांसफर फंक्शन है,
Yes, sir.
उसका कुछ टाइप और ऑर्डर होगा. अब समझने वाली बात यह है कि द स्टेडी स्टेट response analysis depends on the type of the system. Remember, type of the system. अगर स्टेडी स्टेट रिस्पॉन्स एनालिसिस की बात करें तो हम लोग टाइप को पढ़ना पड़ेगा. व्हाट इज द टाइप? इट मींस व्हाट इज द नंबर ऑफ पोल्स lying at the origin. Okay, and also it is very important, the type of system is determined from open loop transfer function. Remember, open loop transfer function, that is the GSHS, right? फिर से मैं बोल रहा हूं, any of the transfer function specifies their type and some order, and the steady state response analysis depends on the type of the system. And what is the type? How the type will be defined? How the type will be defined? The type of the system is determined from their open loop transfer function. Remember, GSHS, open loop transfer function. मतलब ओपन लूप ट्रांसफर फंक्शन GSHS जो आएगा, उसका पोल देखेंगे कि ओपन लूप पोल, ओपन ये जो नंबर ऑफ पोल्स है, ये कौन सा पोल है? इट इज नॉट अ क्लोज लूप पोल, इट इज द ओपन लूप पोल. रिमेंबर, दैट व्हाई आई एम टेलिंग it is determined with the help of the open loop transfer function. So number of open loop poles है, this is the open loop poles. Number of poles lying at the origin केवल कहना ठीक नहीं है, you have to tell the number of open loop poles lying at the origin, right? Okay, the second thing I want to mention here, the number of open, it means the number of open loop poles occurring at origin, it determines the, क्या कह सकते हैं उसको, type of the system. Agree? ठीक है? Any doubt? However, now the transient analysis, दो तरह की बातें हैं. The transient state analysis depends on their order, the order of the system, right? And order, how the order will determine? The order of the system, the order of the system is determined from closed loop transfer function. It is, what is this? This is the highest power of any characteristic equation, of any characteristic equation, right? That is 1
Yes.
plus GSHS is equal to the 0. The highest power will determine the order of the system. Agree? Yes or no? Now the problem was that the question is given like this: the transfer function of a certain control system is Cs upon Rs is given as 1 upon S plus 1. Comment on what is its type and order R. Order R, option 1 0 comma 1, 1 comma 0, C 1 comma 1, and D 1 comma 2. And this question has been asked in the GATE exam. You can verify. And your answer was type option A. Yes or no?
Yes, sir. Type 0
Your
or 1.
option was 0 and 1.
Yes, sir.
But this is wrong. Why? Solution.
सर सी होगा क्योंकि आंसर
Yes. C होगा, क्यों होगा?
Sir,
सर क्योंकि क्लोज सी एल टी एफ है
Sir, because
जब ये
ओरिजिनल निकालना
ट्रांसफर
पड़ेगा
फंक्शन,
सर
मैं समझ गया
CLT
बात,
निकालना।
मैं समझ गया. ट्रांसफर फंक्शन मीन्स,
CLT.
yes,
Yes.
transfer function means it is nothing but the gs upon 1 plus gshs. Yes or no?
Yes, sir.
yes, sir.
Okay.
CLT.
And when you assume that, I'm assuming that the system is unity feedback is given, so it is gs upon 1 plus gs, and it is 1 upon s plus 1. So it is picture is very clear that the characteristic equation having 1 s plus 1, so the order is 1 because the closed loop system. But when you find the gs, when you find out the gs, then it will come like, when you solve this, s gs plus gs is equals to 1 plus gs. Yes or no? Yes or no? When you
Yes, sir.
solve this,
Yes.
1 by
gs
SI.
gs will become 1 upon s.
1 by S.
1 by
Oh,
s,
yes, sir.
right? 1 upon s. So number of open loop pole lie at the origin is 1. So type is 1. Yes or no? So the answer
Yes, sir.
is 1 1, not the 0 1 or 1 0 or 1 2. Right? It is clear? It is clear?
Yes, sir. Yes, sir.
Okay. So next question, on the basis of this you can solve a unity feedback control system. As I assume that you will give the answer of this question in correct way, has gs is equals to 10 s plus 2 divided by s square s plus 5. Now comment on their type and order. What is the type and order of the system? What is the type and order of the system?
Type 2 order 3.
Type 2 order 3. Very good. Type 2 order 3. This is the correct answer. Because GS is given this open loop transfer function. Okay. Based on this, you can determine. So this is all about. Achha, one more thing that I want to discuss here, because this will be used in the next, in the further example. So that is the steady state error. Okay. Steady state error. And I hope you all of you know how it is will be determined. So there is the system gs, and let's say there is the hs. Okay. And there is the ys here.
Hello.
Yes. What happened? So error is here, right? So what is the error? Let's say this is the cs. So ES is nothing but the RS, or let's say this is the signal BS. RS minus BS.
BS.
And you can write here R, what is BS? BS is nothing but the यहाँ पर क्या आ रहा है बेटा? GSHS. इसमें
So
क्या आ रहा है?
GSH.
GSHS, right? GSHS. Okay. So, and what is the, sorry, CS into, sorry, not the GS,
The
sorry,
CSH,
the
sir.
CS.
Yes,
Yes, well, thank you for the correction. And what is the CS? What is the CS? So what is the CS? What is this? Is the CS? What is CS? CS is nothing
So
but
ESGS.
ES into GS. Very good. ES into GS into HS. So when you calculate the ES will come RS
RS upon
divided by 1 plus
1 plus GSH.
GSHS. Right. RS upon 1 plus GSHS. ठीक है. और अगर हम steady state, what do you mean by steady state error? ESS. What do you understand by the ESS? ESS means steady state. When this will come? Is it the, let's say this is the your input, and let's say this is the output. So this is the output will come like this one, right? So after the infinite time, after the long time, this will going to settle, right? And then you are going to calculate the error, and this error, whatever the error will come, this error is not the steady state. It means ESS is nothing but the error between the input and output, but it is defined at the infinite
Limiting
time.
process.
It is defined at the infinite time. Okay. So ESS is nothing but the limit t tends to infinite ET. Okay. So limit t tends to infinite को जब आप लाप्लास लगाएंगे, है ना, in its final value theorem, when you apply the final value theorem in this equation, it becomes limit s tends to 0 s into ES. Okay. S into ES. So the steady state error ESS becomes s into क्या बन जाएगा बेटा? RS अपॉन 1 प्लस GSHS. ये बन गया यहाँ पर. Yes or no? So ESS is nothing but the limit s tends to 0. ESS is nothing but the limit s tends to 0 s into RS upon 1 plus GSHS. We will use this equation in the PID controller and another. Right? Any doubt? If you have any query, you
Yes.
may ask. Otherwise, I will proceed further. So this is the one part of the discussion today. This is the one part of the discussion today. Now,